video is to help you prepare for their last skill test, which will cover similarity, rigid transformations, and dilations. Similarity we had last time, so I'm not going to go over that on the cheat sheet. First one we're going to go over is rigid transformations. So rigid transformations means transformations that are preserving congruency. In other words, movements that keep the same object, same size, same shape. There are three of them. The first one is translations, which is left-right in 2D anyway, up-down motion. And we write it as x plus something, y plus something, or as what's called a transformation or translation vector, which is written as two numbers, say 5, -3. And I'll write these in the same way, actually, 5, -3. The x will move it right here. This part right here goes left, right. In this case, right by 5. In this case, right 5. This one is up, down. In this case, down 3. When you're moving an object, translating it or reflecting it or rotating it, make sure you label it and then you go from a letter to that letter primed. And if it's already primed, go to double prime. Okay, that's translations. The next one is reflections. Reflections are a mirror image across the mirror, which in geometric terms is called the line of symmetry. We only really did reflections across y equals x, y equals -x, and vertical and horizontal lines. So that's all will be on the test. How do you write that? You write that as a big R and then the name of the equation of the line. Say y equals, I don't know, x plus 2. And that will give you a reflection. When you look at it, make sure when you're doing your test, I drew a little picture here, that if you have an object like this and you reflect it, that it ends up looking symmetric after you reflect it. That's pretty close, maybe a little tall. And how do you reflect it? You count the distance here, let's call that d, and that has to be the same distance d to the other point. So if it's on a vertical line here, for example, go 1, 2, say 1, 2 on the other side and put the point in. Same thing if it's on a diagonal line. Count to the diagonal across the diagonals perpendicular to this line. Say if you just tilted this, go 1, 2, 1, 2 again. Same idea. If you want to reverse this and find the line of symmetry from two objects, so to reverse and find line of symmetry, simply take the mathematical midpoint between each point on A and A prime. Okay, that's reflections. The next one is rotations. You can pause that if you need to catch up on writing. Next one is rotations. Okay, rotation is going around in a circle. Around, so rotating, another word for rotating, and spinning, say. Spinning around a center, quote that, let's do it underline, center of rotation, which we typically did as the origin, but last stuff we did, we were doing around different points than the origin. Okay, so how do you do that? First of all, you need a series of equations. We only did 90, 180, 270, so I'm just going to do those. 90 degrees clockwise, 180 degrees clockwise, 270 degrees clockwise. And if you happen to get counterclockwise, that's the same as 270 degrees counterclockwise, 180 degrees counterclockwise, and 90 degrees counterclockwise. So you just use one set of equations. The equations are, if you start with a given point, on the 90 degree clockwise orientation, you just flip the coordinates and change the sign of the last one. So xy becomes y, negative x. For the 180, you don't flip them. Be careful with that. And you just change their signs. This does not mean make them negative. It means change their signs. So if they're positive, it becomes negative. But if it's negative, they become positive. And this one also is a switch, just like the 90. Except in this case, you make the first one negative. And that is it. If you're rotating around a center, not 0, 0, then redefine the center of dilation, or center of rotation, sorry, center of rotation as 0, 0. I think you did that in the last one, and then just redefine all the points there, and then use these same sets of equations. Redefine all points. So you just need these equations, basically. Okay, that's rotations, and that's the last of the rigid transformations. So what you're going to be able to do on this overall, you might have to write some rules. You might have to move objects or points, reflecting, rotating, or translating, or a combination of those. Okay, next, dilations. Dilation is also a transformation, but it preserves similarity, which means same shape, different size. So if, let's give the, we had two ways of doing this. One is we did it by coordinates, in which case it was a very simple transformation. It's just xy became kx, ky. You basically multiply the points by what's called a scale factor. And the scale factor meant the same thing it meant in similarities terms. It was the end dimension, the destination dimension, so that's probably a little unreadable, divided by the original dimension. And given that it's growing with the same shape, you can pick any side you want as long as you're doing the corresponding one. Okay, so that's one way we did it. The other way we did it, let me do something about k first though. If k is bigger than 1, the figure is getting bigger because it's the end dimension over the original dimension, and we call that enlargement. If k is less than 1, we call that reduction. Okay, so that's one way we did it, and this was always around the origin only. This equation only works if you're dealing with the origin. Okay, the other way we did it was by lines of dilation. And that can be anywhere, does not have to be the origin. Can be, but doesn't have to be. Does not have to be around 0, 0. And what we did there, I'll just draw a picture of it. It's not going to look great because I'm not on a graph board or anything. But if I have a figure A, and I want to enlarge it around, say, a center of origin, which I'll call this, center of dilation. Center of dilation. All I do is I connect this to this point, these points on here, with a line. That's called a line of dilation. Like so. Use a ruler, by the way, on the test, or a straight edge at least. And then, if I want to say have a scale factor of 2, I just take this distance from here to here, and I double it. So I go an equal amount out here and draw it. Do the same thing here, same distance here, go out to here. That's a little too far, looks like. And then out here, same distance here, out to here, and then redraw it. And again, do this all with a ruler. If you do that, this will be A prime. If you do that, this will be, this right here will be double that size. As will this. This will be double that, and this will be double that. So you can check afterwards if you're done. You can also reverse the direction of this and find the center of dilation by just connecting these points from the figures, all of them, and then hitting this point right here, which will tell you the center of dilation. Okay, that is it. One thing I think I forgot go back to rotations a second. I realized I didn't give you the rule for that. So go back to your cheat sheet part of rotations. Rule for that is R, that means small r, means rotate. You put the angle, say 90 degrees, you put the direction, clockwise, and you put your center of dilation, which is often 0, 0, but not always. Sorry, rotation, sorry. It's often 0, 0, but not always.